Welcome to our channel Learning Math. In this video, we're going to learn the second part for the properties of square roots. First, we're going to start by the square roots of even and odd powers. As you see, for example, if we have radical 2 to the power 10. Even powers, you know that even number is divisible by 2. And the power 2, which is a square, cancels the radical. So here when we have even power, for example 10, we can divide it by 2. We get here 5. So it's 2 to the power 5 all squared. Now square cancels radical. What remains for us? 2 to the power 5. So whenever we have an even power, we should divide it by 2 in order to get the power 2 square outside, which will cancel the radical. Also here, as you see, we have a radical 3 to the power 8. 8 is an even power. We can divide it by 2. We get the answer 4. So it's 3 to the power 4 all square. Now square cancels the radical. What remains for us? 3 to the power 4. The same here, radical 7 to the power 6. We can divide 6 by 2. We get 3. So it's radical 7 to the power 3 all squared. Square cancels radical. What remains? 7 to the power 3. Now what about this example? Here we have radical 40,000. If you know something, 40,000 we can write it as 4 times 10 to the power 4. Why times 10 to the power 4? We have here 4 zeros. Now we can replace them. 4 is 2 square and 10 to the power 4. If you know something, 10 to the power 4, here 4 is an even power. We can divide it by 2. What remains for us? 2. Since 4 divided by 2 equals 2, then it's 10 to the power 2 all squared. So first here we distributed the radical. It's radical 4 times radical 10 to the power 4. Now radical 4 is radical 2 square. We replace 4 by 2 square. And 10 to the power 4 even power. We divided it by 2. We get 10 to the power 2. Now square cancels radical. We get here 10 to the power 2. Also here square cancels radical. What remains? 2. So it's 2 times 10 power 2 equals 200. Another example, if we have here, for example, radical 0.0016. Note that we can write it as 16 over 10 to the power 4. Over or divided by, since we have a decimal number. Why is over 10 power 4? We have 1, 2, 3, 4 digits in the decimal part, so it's over 10 power 4. Now we can distribute the radical since we have divided by, which is over. So radical 16 over radical 10 power 4. 16 is 4 square. 10 power 4 even power. We divide it by 2. We get 10 power 2. So here square cancels radical. What remains for us? 4 over. Here square cancels radical. What remains? 10 power 2. 4 over 10 power 2 is equal to 0.04. Now what about the square roots of odd powers? How should we solve if we have an odd power? Know something. For example, 7 is an odd number. If we subtract 1 from 7, what remains? 6. 6, which is an even number. In general, whenever we have an odd number, if we subtract 1 from it, we will get an even answer. So if we pick up 1 from the odd power, we will get an even power. Here is an example. Radical 3 power 5. If we picked up 3 alone, what remains for us? 3 to the power 4. How did we solve it? 3 power 5 is 3 times 3, 5 times. We have picked up 1. What remained? 4, which is 3 to the power 4. Now we can distribute radical since we have time. So it's radical 3 power 4 times radical 3. 3 power 4 even power. We can divide it by 2. So it's 3 power 2 all square. Now square cancels radical. What remains for us? 3 power 2. So it's equal 3 power 2 times radical 3. 3 power 2, which is 9. So it's 9 radical 3. Another example. Here we have radical 7 to the power 9. Also odd power, not divisible by 2. We pick up 7. What remains for us? How many sevens? 8 sevens. So it's 7 to the power 8. Now we can distribute radical since we have time. So it's radical 7 power 8 times radical 7. Now here 7 power 8 we have even power. We divide it by 2. Here square cancels the radical. What remains for us? 7 power 4 times radical 7. Radical 7 remains the same since we have 7 is not squared. There's no square to cancel this radical. So what remains for us? 7 power 4 times radical 7. Now something which is very important. If we have, here is another example, radical 5 power 7. Odd power, we picked up 1 to get an even power, we solve it by the same method. If we have, for example, radical 25 million, here we can write it as 25 times 10 power 6. Now we can distribute the radical since we have times. Radical 25 times radical 10 power 6, 25 is 5 square. And 10 power 6 we can write it as 10 power 3 all square. Square cancels radical, what remains? 5 times 10 power 3 equals 5000. Well, square roots always give us a positive answer. This is a very important property for radicals. Whenever we have radical, the answer of this radical will be positive. How do we know it? Something which is very important. If we have, for example, radical for minus 3 all squared, even if we have here minus, we cannot say directly that square cancels radical and minus 3 remains. This is completely wrong. Why? First of all, we should solve the power. Minus, and we have even power, minus becomes plus. What number takes the power? We have the number 3 here, so 3 square. So it's equal radical plus 3 square. Now we can say that square cancels the radical. What remains for us? Plus 3, which is here 3. Another example. If we have radical pi minus 4 all square. Note something which is very important. We have that pi equals 3.14. Isn't it less than 4? Well, we are subtracting smaller minus greater, we will get a negative answer. When square cancels radical, if we write it pi minus 4, it will be negative. This is completely wrong. Square roots should give us always positive answers. So here we write the greater minus the smaller, so it will be 4 minus pi to get a positive answer. So sometimes we should pay attention, we should reverse them. We write the greater. If we have minus, we write the greater minus the smaller as an answer of a square root to get a positive answer. Let's solve some examples together. Radical pi minus 5 all square. Pi is 3.14 less than 5. Square cancels radical, but if we keep pi minus 5 smaller minus greater will be negative, so we should write it positive, greater minus smaller, so we write it 5 minus pi. Another example, radical 1 minus pi all square. Here pi is 3.14 greater than 1. Square cancels radical, but can we write smaller minus greater? Sure not. So it will be pi minus 1. We reverse them. Radical minus 4 all square. Well, square should cancel the radical, but can we write it minus 4? Sure not. The answer of a radical should be positive, so it will be plus 4. Another example, radical pi plus 5 all square. Here square cancels radical. What about pi plus 5? We don't have minus to check it up, greater minus smaller. Here we have it plus. Pi plus 5 is positive itself, so we can write it directly pi plus 5. Now radical 3 minus pi all square, we can write it here, square cancels radical, but 3 is less than 3.14. So we write greater minus smaller, so it's pi minus 3. Now what happens if we have the sign minus outside? The sign minus outside does not affect the answer of the number below the radical. Here radical of minus 7 all square is plus 7. But we have minus outside, so it's minus times the plus 7. Minus times the plus minus, it will give us minus 7. The answer of the square root is a plus 7, it's positive. But since we have minus outside, then we multiply it by minus. Well, now let's start by other examples which are also very important. Here minus radical, minus 9 square. Square cancels radical, but the answer should be plus 9. But we copy here the minus which is outside. Minus times the plus gives us minus 9. The same here. Another example, minus radical 2 minus pi all square. If you note something here, square cancels radical, but 2 is less than pi, which is 3.14. We should write it greater minus smaller, so it will be pi minus 2, but we keep on minus, which is outside. We should copy it. Why? If you note something, when we have minus and we have here minus between them, we can reverse them. So we can write it as 2 minus pi. How it comes? Minus times plus minus pi, as you see. Also minus times minus plus 2. Here we have plus at the beginning. We can write it or not. Now some numbers should be simplified using prime factorization in order to determine their square roots. We have learned square roots of even powers, odd powers. What about square roots of numbers that we don't know their power? 128. If we want to write it as a power or a product of powers, how to write it? We should start by prime factorization. 128 divided by 2 gives us 64. 64 divided by 2 will give us 32. Also divisible by 2, it gives us 16. Now 16 divided by 2 gives us 8. It's also divisible by 2. We keep on dividing it, gives us 4. Divided by 2 gives us 2. Divided by 2, 1. Sure, we keep on dividing it till we reach the answer 1. If you know something here, we can write 128 as 2 power. Here, how many 2 are we having? 1, 2, 3, 4, 5, 6, 7. So it's 2 power 7. Now we can say that radical 128 is equal to radical 2 power 7. As you see, we have odd power. Now the square root of an odd power, we pick up 1. What remains? 2 power 6. Even power, we can divide it by 2. We get it 2 power 3 all squared. So here square cancels radical. What remains for us? 2 power 3 times radical 2, which is 8 radical 2. Another example, we have 75. How to perform its prime factorization? It's not divisible by 2, but it's divisible by 3. 7 plus 5 is 12, multiple of 3. Well, 75 divided by 3 gives us 25. 25 divided by 5 gives us 5. Also 5 divided by 5 gives us 1. So here we can say that 75 is 3 times 5 square. Now we can replace 75 by 3 times 5 square. Here we have 5 square. Square will cancel the radical, so we can write 5 directly outside the radicals. Only here in this case, since we have times. So it's equal to 5 radical 3. Sure, 3 remains below the radical since it's not squared. Well, this rule is only available, we can pick up out directly the square number only in case we have times or divided by and not plus or minus below the radical. This is very important. Well, if we don't want to perform prime factorization, we can memorize some numbers. Here we can say that 80 is 5 times 16, 75 3 times 25, 48 3 times 16, and 72 is 2 times 36. Here if you note 16, we can write it as 4 square, 25 5 square, also 36 is 6 square to solve the radicals. We can also perform a tree method to write the prime factorization. You know that 72 is 8 times 9, 8 is 2 times 4, 9 is 3 times 3. Also 4, we can write it as 2 times 2. Now all these numbers are prime numbers. Here we can count them. We can say that 72 is 2 power 3 since we have a 3 2 times the 3 power 2. In this case, we can solve radical 72. In the third part, we're going to learn how to add, subtract, and multiply square roots. Now, thank you for watching. If you enjoyed this video, please like, share, and subscribe.